Hello. Should be live now, hopefully. I'll give it a second, let people join. Okay, just giving it a second, letting people join. Hi Ben. Nice to see you. Going to be a similar format to last week's session, where going through basically exam questions. The best practice to sit an exam, unsurprisingly, is practicing exam questions, and they'll get harder as we go through. But yeah, these are all exam questions. Some of them foundation, some of them higher. Obviously, as we get beyond halfway, really, well, kind of a third of the way through, I should say, actually, because it's kind of those crossover questions, which is then the higher questions, really, isn't it? At the end of the foundation, start of the higher papers. I've mixed in some questions from GCSE papers and AQA papers, so different exam boards as well. So they might look slightly different. That's why. Okay. So yeah. Right, I'll give it one more minute and then I'll make a start. In the time that I'm waiting here, you can have a go at, or at least think about the answers to these questions, how you do them. These are questions from the start of foundation papers. You might have seen these before because you might have done these papers before, but they're from different papers. So yeah, you might remember one of them, but they're not all from the same paper, kind of thing. And generally, think of these kind of questions, these first ones, as kind of a warm-up. Sunday morning, getting your brain in gear. It's 10:30. Can I still remember how to do maths? And if anything's not working, let me know. So if you can't hear me, you should be able to, but if you can't, just type in the chat, let me know. Just like last time, the setup, we've got 47 days really, a little under 47 days, because it'll be in the morning, the exam. All three of them at Excel at least are in the morning. 47 days till the exam, which is about a month and a half really. You take out the 2 weeks for Easter, you've got about 4 weeks. And in fact, I'm pretty sure the Excel one is the end of the 4th week, so it's on the Friday. After Easter, 4th week back. Yeah, got the average grade boundaries there as well, and again they're from MathsBot. So if you wanted to have a look at exam grade boundaries from different years, it's got them all on there. Different exam boards as well, and then the weightings for each of the topics in the exam. So foundation and higher, and that again, that's at Excel. Recommended websites, of course you might know other ones that you use, and that's absolutely fine. They're the ones that I use most frequently and so would suggest using, and they've got loads of great resources on there. The GCSE Maths questions one is third. I was just saying there how I've used those before. I would recommend using them. I haven't used the GCSE Maths questions myself really previously, but just like I said at the start, the best way of practicing to sit a test is to practice past tests and assessments, past exam papers. That'll give you the best practice, because not only is it practicing the right topics, but it's also the way that you answer the questions, the clues in the question, and the hints as to what they want you to do while you're reading it, and what you would need to use and what you're expected to use. So all those kind of things, exam technique, timing as well. Timing is one of those things that you need to practice, and if you're not doing the exam papers, you're not going to practice. So really important that actually you sit there and you time yourself an hour and a half, do the paper, because that will give you a little bit of pressure. But the closer you can get to exam technique, and exam conditions, the more relaxed, more comfortable you're going to feel when you're sitting the exam. So that is really important. And I did want to talk about at the start of this session as well, revision, because I'm sure most of us will be thinking and doing revision over Easter and thinking about how to do it. The first thing is make yourself a timetable, is what I would suggest, and really it's up to you, and what you think about how much time you should be spending on different things. So although I'm a maths teacher, I'm aware you've got other subjects. Timetable it in, make a timetable, and stick to it. Okay, so you've got to put the pressure on yourself as much as anybody else to say, look, I've made this now, so I've got to stick to it, because if I don't, it's not going to work. And then you don't want to look back afterwards and say, oh well, I could have done this, I should have done that, if only I'd stuck to my timetable, then I would have done better in XYZ subject. So yeah, timetable, you have to have that, and you have to make it yourself. It has to be personal, so you've got ownership of it as well. But then making sure also when you make that timetable, you plan in time for breaks, because that's just as important. Otherwise you will burn yourself out, and that's when kind of you won't stick to your timetable. So you've got to plan in those breaks. They're really important. And I think when I did it, I had a break, and this is only what I did, so it's completely personal, something like a break every 2 hours, or you could do an hour and a half. Could be a 15-minute break, a half an hour break, an hour for lunch, different things like that. But it could be longer. It could be you do 3 hours in the morning, 2 hours in the evening, whatever you want to and whatever you feel is best for you. Now also you need to identify, you need to know, and in most cases you will know, what topics you need to work on. From there, you need to practice those topics. Don't waste your time practicing things you can already do. Practice things that you can't do, and if you completely don't know how to do them, watch videos. Put it in the chat what you want me to go through, and I'll go through it. Or if it's included in one of these sessions, then this should help as well, and that's the point. Otherwise, there are loads of places to watch videos about it. There's other YouTube videos. I might have gone through some on the previous exam papers that I've done. Or there's places like Corbett Maths. There is Maths Genie that's in those recommended websites that you can use with videos on different things. So on every topic basically, and they've got on Maths Genie the questions for each topic, past paper questions, which you can use to practice. And also you need to practice, like I've said previously and earlier on today, past papers. So you might want to spend some time working on topics that you can't do, then do a past paper, mark it, make sure you mark it so you know what you're getting right, what you're getting wrong. It's a pointless task doing the paper if you're not going to mark it. And then from each test you do, you can identify, well actually I don't know how to do that, so I'll do a little bit of practice on that, 20 minutes, half an hour. I don't know how to do that, I'll do a little bit of practice on that topic, and then do another test, and hopefully you should see improvement. That's the whole point. And if you're not, you might need to go back and practice those topics a little bit more. But it's kind of a cycle, and this is what I would suggest at least, is of past paper, what don't I know, practice topics, okay, practice another past paper, practice some topics, practice another past paper. For certain things I would also use revision cards. So if there are things like the quadratic formula, for instance, or transformations of graphs, that or exact trig values that you just need to know, I would suggest using revision cards to obviously write down what you need to know, and then use that to test yourself or get somebody else to test you as well. And so whilst you've obviously heard about different revision techniques before, they don't need to be, I'm going to use a maths term now, mutually exclusive. You don't need to use just one thing. You don't need to just do past papers or just do revision cards or just use another revision technique. You can use multiple revision techniques. It's not just one way, not just one revision technique is going to be, you know, the magic solution to revision. So I would suggest, you know, using different revision techniques, and then, you know, if one works better than the other, or if maybe it's better for different scenarios, like with you know, those things that you just need to know, quadratic formula and so on, you're using that technique for that specific purpose. Okay, right, if there are any other questions about revision or anything else, you know, like I always say, put it in the chat. And just to mention at the start, I'll mention it again before the end, you know, if these videos are useful, please like the videos, because that tells me they're useful, and you know, in a sense that makes me, if they're useful, then, well, that's the reason I'm doing them. So then I'll keep doing these videos and these sessions to help in the lead up to the maths exams. Okay, and also there is the in the bottom left corner, the QR code if you did want to support the channel in that way. Okay, I'll get started on these questions now. Excuse me. So it says, on the grid, reflect the shaded triangle in the mirror line. So we've got this mirror line here. Now, two of the vertices, the corners of this triangle, are on the mirror line, so they're not going to change. Now, if they don't move under a transformation, and we don't need to know this for this question, but if points don't move under a transformation, they're called invariant. Now, like I say, we don't need to know that for this question, but these 2 points, they're unaffected, they're unmoved by the transformation, by this reflection. So they're what's called invariant. Okay, so I'll just write that, I'll write it over here, invariant. I can't remember you know, I don't know the word for word definition, but essentially invariant means unmoved by transformation, and that doesn't have to be a reflection, that can be other transformations. Now that is something that can and does come up on, you know, higher papers as well. If you see the word invariant, that means it doesn't move. Okay, now this other point is a distance of 1, 2, 3 squares away on the right hand side from the mirror line, so we need to do 3 squares away on the left hand side of your mirror line. Then use a ruler, make sure you do use a ruler, and join those up. Okay. Next question, 3 squared. 3 squared means 3 times 3, so that's 9. And if it's cubed, then there's 3 of the number multiplied together, and so on. Next question. Teaching my year 7s recently, they were asking me, when do we use you know, bib maths, bob maths? When do we use that? Do we use it here? And I say to them, the order of operations is always important. You know, you always do it. So it's not a case of when do you use it, when don't you. You always follow or do the operations in the order that they should be done. And basically, you know, people can remember it in terms of bib maths or bob maths, but essentially it's which operations are more powerful, if you like. So, you know, the brackets, that's an indicator that bit has to be worked out first. That's essentially what brackets are. So we have to do 3 add 2 first of all. Okay, 3 add 2 is 5. 20 divided by 5 is 4. Now what I mean by more powerful is essentially, well, multiplication is repeated addition. Okay, so multiplication is a quicker way of adding something up loads of times. Addition and subtraction you do left to right, so even though, you know, in terms of bob maths or bib maths, you have addition and then subtraction, they work left to right. Now the reason for that is because basically addition and subtraction are one and the same thing. So if you have something like 3 add I've written this the wrong way around really, but I'll carry on. 3 add negative 5, that's the same as 3 subtract 5. So actually you can write every subtraction in terms of an addition, and likewise you can write every division in terms of multiplication. So if I do 10 divided by 2, that's the same as doing 10 times by the reciprocal of 2, which is a half. So that's why, you know, in terms of order of operations, multiplication and division you do left to right, addition and subtraction you do left to right as well. Multiplication and division are more important, so you do them first, because multiplication is repeated addition, it's more powerful, and indices, that is repeated multiplication, so that's more powerful than multiplication, so you do that before your multiplication or your division. And then brackets, like I said, is an indicator of something that needs to be worked out first of all. Okay, the next bit is substitution question. So work out the value of y when x equals 4. This is the equation of a straight line, and this is the gradient, 6x. So if I go along 1 unit, I have to go up 6. This minus 5 here, that's the y-intercept, so that's where it crosses your y-axis. Work out the value of y when x equals 4. So we're just going to substitute in, or we're going to change x for 4. So 6 lots of 4, 6 times by 4 is what that means. Take away 5. Okay, so 6 times 4 is 24. Take away 5 is 19. And that's our answer, y is 19. Last question on this page, write these numbers in order of size, start with the smallest number. We need to change all of these into either fractions, decimals or percentages. The easiest one is decimals. The most difficult one to compare is fractions, because you've got to make sure they've got the same denominators. So I'm going to change these all into decimals. A half, I know, is 0.5. And speaking about things to write on flashcards, there are certain fractions, decimals, percentage conversions that you need to know. So, you know, like a half, a third, a fifth, a quarter, because they will allow you to work out 3/4 and you know, 4/5 and so on. So you need to know those. 0.5, 0.55, 0.45. Now the next thing you probably want to do is make sure they've got the same number of decimal places, so then you can compare them as if they are, you know, without the 0 point, if you like. So like, it's not, but you could think of it as 45, 50, 55 in terms of comparison, to help you know which one's the smallest. Now when you write these down on the line, you need to write down the original. So 45% is the smallest. Then it's a half, and then it's 0.55. Moving on to the next questions. This one is about sequences, and it's sequence of patterns. Again, this is a type of question that, you know, if you struggle with it, essentially it's practice, and you need to look at what's happening with the patterns. But the more you practice these, because there are different types of patterns obviously, the easier it will be. So 1 square here, and then we're adding a square to the bottom and to the right. Okay, so that's 1 and 3 down, 3 right. So I would want to use my ruler for this. So we've got 4 down and I suppose 4 right, if you think about it, if you include that top one. So we're going to go 5 down, because we're doing pattern 5, and 5 right, including that original one. Okay, and should always use a pencil to do this. I'm using a pen so you can see it more clearly. Always use a pencil. While I'm talking about equipment as well, what I would suggest is to make sure that you have all the equipment that you could possibly need in the exam, because what you don't want to be doing is trying to find things or ask people for things, whether that's, you know, friends, teachers, or invigilators for equipment. You want to be as stress-free as you can be in the lead up to your exam. And also, you know, things like protractors and compasses, how are you going to practice these things if you don't have them to hand for your revision at home. Okay, so yes, make sure you do have everything you need, protractors, compasses, and it's all sorted out, ready to go in, so you're as stress-free as you can be. Okay, so pattern 5, 5 length 5 down, and width 5 along the top. So it's basically pattern 4 with an extra square at the bottom, extra square to the right. Complete the table, pattern number, and then the number of squares. So 1, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. The reason I've done that is to check the way, well, to check that I'm doing it right, essentially, to check that I'm counting these squares right, so that when I come to do this one, it's the same process. I know I'm going to get it, or can be very confident I'm going to get it right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Seems simple, and you're probably thinking, why have I done that? You don't want to make a silly mistake or have misread the question. Okay, so say that is, you know, well, say it's the same thing, number of squares, but for some reason people are counting, you know, the height here, that's 1, and then that's 2, 3, 4, 5, and they just put 5 in there and just don't think. That's why you need to use these numbers to help check. Now after that, we could draw pattern number 6 and we could think about actually what's going to happen, or we could look at what's happening to the sequence here. Add 2 is the term to term rule, because that's what gets me from one term to the next. So 9 add 2 is 11. Now it doesn't say this on this question, but if it asks you to work out the nth term, if it's going up in 2s, that's like the 2 times table. Now the 2 times table would be 2n, 3 times table 3n, 5 times table 5n, and so on. And then basically one way you can do this is, how do you get from 2 to the first number? Because in the 2 times table I start with 2. Here I start with 1. How do I get from 2 to 1? Take away 1. So that would be the nth term for this sequence. Another way you can do that is go back to what's called the 0th term. Okay, so if I'm going backwards, I'm going to take away 2. That gets me minus 1. Your 0th term will always be what you add on or take away. Okay. Moving on now to the next questions. Write down the value of 6 in this. So units, tens, hundreds, thousands. So 6,000 would be the answer. Relatively straightforward, but yeah, you just need to make sure you're thinking about actually what does that number represent. Units, tens, hundreds, thousands. Simon buys some candles. Each candle costs £2. Simon pays with a £20 note. So I'm thinking at this point this is a change related question. He gets £6 change. Work out the number of candles Simon buys. So if you got £6 change, then each candle, sorry, not each candle, he must have bought candles that had a total of 20 take away 6, so £14. 14 divided by 2, because that will tell me how many, well, the cost of how many candles fits into 14, so thus how many candles he bought. So 14 divided by 2 gives me 7 candles. Okay, moving on. Write 124 as a product of prime factors. Okay, now I'll show you the way that I do this. Makes sense as I'm doing the live stream, doesn't it? 124 is a product of prime factors. We need to know what that is. So prime numbers, not 1, because it has to have 2 factors. 1 isn't a prime number. 2, 3, 5, 7, and so on. So it needs to be one of those numbers. It has to be a factor. So it has to. We have to be able to divide 124 by it, and product means multiplication, means times. So I'm going to start off. I know this is even. It ends in a 4. So 2 times by half of this is 62. Now I should have mentioned at the start, all of these questions that I've got here are non-calculator questions. Now circle the prime number. The reason I've done that, chosen non-calculator questions, is basically because the same topics could come up on a calculator paper, of course. You just use the calculator for your working out. But if it's on a non-calculator paper, then essentially we're going to be practicing both. We're going to be practicing, the topics and the methods, but also actually the calculating of the answer and of the working out. Okay, I'll carry on with this. So 2 times 62. I should just double check that. So 124 divided by 2. 2 doesn't go into 1. Carry my 1. 2 into 12 goes 6. 2 into 4 goes 2. Yes. So carry this 2 down. I'll tell you why in a second. 62 is 2 times by 31. Okay, now 31, what can I divide that by? Can I divide it by anything apart from 1 in itself? Now we need to check. So it's not even, it doesn't end in 2, 4, 6, 8 or 0, so I can't divide it by 2. Can't divide it by 3 because 10 times 3 is 30. Can't divide it by 4 because it goes 28, 32. Can't divide it by 5 because that would go into 30, 35. Can't divide it by 6 because again that goes 30, 36. Can't divide it by 7, that goes 28, 35. Can't divide it by 8, 9, 10. And yeah, can't divide it by basically any other numbers apart from 1 and 31. Now I know that's a prime number, so if you know it's a prime number you don't need to do that check, and that's why you need to know your prime numbers. So if you do see an unusual and uncommon one like that, then you don't have to spend as much time checking it. You can just go, I know 31's a prime number, and stop there. So in answer to the question, 124 is a product of prime factors. 124 is 2 times 2 times 31. Now this question doesn't say an index form, but if it does, you write 2 squared, 2 to the power of 2, because we've got 2 2's, times by 31. Now the reason I said I would tell you this, the reason that I've carried this 2 down is because each row here is 124. This bottom row is also 124. So that maintains the fact that every row will be 124. It also makes sure, if you do it properly, that you don't miss any numbers. The other method, if I don't write that down, then what some people will do is especially if you've got a long prime factor decomposition, they will miss some of your prime factors because they'll be looking up here, or they'll forget to look up here, further up in your working out. So they'll miss some, which is why it's also useful to carry your prime factors down. Next question, find the value of y. Now again, this is one of those things that you just need to know, and that is angles around a point sum to 360 degrees. I'll put add up to. Some people might forget what the word sum means. So I do 360, take away 70, and it's a non-calculator paper, or these are from non-calculator papers, so I'm going to use my written methods. 0 take away 0 I can do, that's 0. 6 take away 7 I can't do, so I need to borrow 1, so that's 2. This is 1. 16 take away 7 is 9, and then I've got 2 there, 290. Give a reason for your answer. I've written it up here. Angles around a point. And essentially when you're writing down the reason for your answer, it's that reason that you've thought of. It's what you've used to work out the answer. So just write down, what I've thought of here, what you've thought of when you're doing these questions. These reasons don't have to be word for word, okay? You just have to know what you're doing and just explain it, that's all. This bottom question, we've got pressure is equal to force divided by area. They've given that to us, which is useful and helpful. A storage tank exerts a force, okay, so we've got force of 10,000 newtons on the ground. Got force. The base of the tank in contact with the ground is a 4 by 2 meter rectangle. Right, rectangle, I know how to work out the area. I can do the area. 4 by 2 meters, 4 times 2 for the area of a rectangle, gives me 8 meters squared. Work out the pressure on the ground due to the tank. So we do force, like this says, 10,000 divided by area. So pressure is equal to 10,000 divided by 8. Okay, now we'll need to do a written method for that. So 10,000 divided by 8. 8 doesn't go into 1, so carry the 1. 8 into 10 goes once, remainder 2. 8 into 20, 8 16, that's 2, remainder 4. 8 into 40 is 5. So 1,250. Now the units, think about what we've got here. We've got newtons, we've got meters squared. So it's going to be newtons per meter squared, and the way you write that is newtons per meter squared. That means that for every meter squared, there's going to be a force downwards of 1,250 newtons. That's what pressure is. Okay, it's basically it's an average force for a unit, which in this case is meters squared. Okay, these are getting on to the crossover questions now. Savio Savio leaves his home at 7:30 to drive to work. He drives a distance of 50 miles. Straight away I'm thinking speed, distance, time. Okay, we've got a distance, we've got a time. So I'm going to write that down. Speed is equal to distance divided by time. And if you ever forget the equation, just remember that in Europe they work on kilometers per hour, and kilometers per hour is kilometers divided by hours. That's how it's written. Okay, and that's a distance and that's a time. And overall it's a speed. Savio thinks he drives an average speed of 40 miles per hour. If Savio is correct, at what time will he arrive at work? So we've got a speed, okay, and we've got a distance. Now another way to look at these questions is basically, basically we're going to have to rearrange this. One thing that can make that easier is putting this into what's called, putting it into this basically calculation triangle, and you don't have to do the rearranging then. So that will make your life, if you struggle with or if you find it difficult with rearranging, you can use this. So speed is distance divided by time, so we need distance divided by time, so that means speed has to go here. Now whichever one we need to calculate, we're going to cover that up, and then it will tell us what we have to do. So at what time will he arrive to work? We're looking for time. We need distance divided by speed. Distance is 50 miles, speed is 40. And if you were to rearrange this, I'll do it here, you're going to times both sides by time. That'll get rid of divide by time. So you get speed times time equals distance. Then we are working out time, because we want to know the time it takes, so we're going to divide by speed on both sides of my equals. And there you go. Okay, so we get the same thing as we did up here. Distance divided by speed gives you the time. Distance is 50 divided by 40. That's the same or equivalent fraction to 5/4, which I know that 1/4 is 0.25, so that's got to be 1.25 hours. We need to know at what time you'll arrive to work. Well, 1.25 hours, that's 1 hour, hour, not plural, and we've got 0.25, we've got a quarter of an hour. A quarter of an hour is 15 minutes. That's how long it's going to take. So at what time will he arrive at work? We need to do 7:30, add an hour, add 15 minutes, so 8:45. Now with this question you did have a line to write your answer. If you don't, or say you've written it on there and you've crossed it out, just make sure your answer's clear. So maybe circle it, double underline it, something like that. In fact, Savio's average speed was greater than 40 miles an hour, so he's going quicker than 40 miles per hour. As a reminder, 40 miles per hour means every hour he's going to be completing 40 miles. So if he's going quicker than that, he's going to do 40 miles faster, because let's say, and this is always good to do with these types of questions when they're talking theoretically, how might this affect his answer? If we were to use, well, pick a number basically that is bigger or smaller, in this case greater. So let's go with 50 miles per hour as an example. How does that affect our answer? So if this is 50 miles, then we do 50 divided by 50, which gives 1 whole, which is 1 hour. So he would get there quicker. So that's what we need to say. Where's he going? He's going to work. He would arrive at work earlier. So it's always good to use an example and to think of a number that's bigger or smaller and use that. Next question, 7x subtract 27 is less than 8. The way you solve these is basically, well, it's exactly the same as if it was equals there. So, dashed line, balancing line, that is. Now I need to basically remove everything that has happened to the x. So the first thing that's happened to the x is times it by 7. Then you take away 27. So I need to do that in reverse. So the last thing I said is the first thing I need to undo. So I need to undo this subtract 27. I need to add 27 to both sides. 7x is less than 8 add 27. That's going to give me 35. And then I need to divide by 7 on both sides. X is less than 35 divided by 7 is 5. Now, instead of writing equals, obviously you write this symbol all the way throughout. It's the only difference, exactly the same question, just different symbol. So that means x is less than 5. So x could be 4, 3, 2, 1, 0, negative 1, and so on, negative a million. Okay, 240 cans of drink on a shelf. Each can contains cola or lemonade or orange. We've got 3 things. There's a ratio question. We can tell just by looking at the question. Anyway, the number of cans of cola, number of cans of lemonade, number of cans of orange is in this ratio. Before I read any more of the question, I'm going to work out how many cans there are of each. So I'm going to use this ratio. With ratios, if you watch the previous live stream or any of my videos on ratio, with the past papers, I use a bar model. So 5 wide on the first bar, so that's going to be cola. Bar or boxes, it doesn't really matter what you call it, it's the same process, same thing. I tend to refer to them as boxes because if you need one more or one less, you can just add them on or take them away. The key point is that you treat them as if they're the same size. Then we need 3. 1, 2, 3, and that is lemonade. And then orange. Which, if you know me, not a fan of orange. 5, 3, 2, 240 has to be split into all of these. So all of these added up together in terms of what's in the boxes gives me 240. So I need to do 240 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's easy to do. 240 divided by 10 is 24. Now, just like last time, I've done my boxes really small, so I'm going to have to try and squeeze these 24s in everywhere. Now what I would then do, before I read any more of the question, is work out orange, 48, 3 lots of 24 for lemonade. So you could use a written method if you're not sure. 3 times 4 is 12, carry my 1, 3 times 2 is 6, add the 1 is 72. So that's 72. And then 5 times 24, well, do 10 times 24 and then half it. 10 times 24 is 240, half of that is 120. So that's 120. Now I'll carry on reading the rest of the question. Half of the cans of lemonade, so I'll work that out. Lemonade is 72. Half of 72, that's 36. And 1/12 of the cans of orange are removed from the shelf. Reading so many words at this point, I'm getting them all kind of blended together. 1/12 of 48. So to work that out, you do 48 divided by 12, 12, 24, 36, 48. So that's 4. So we've got 36 cans of lemonade and 4 cans of orange are removed from the shelf. So that's going to leave me with 36 cans of lemonade on the shelf and 4 cans of, 44, 48 take away 4, 44 cans of orange on the shelf. Work out the number of cans of cola as a percentage of the total number of cans of drink remaining on the shelf. Okay, so we're now going to have, I'll just split this up, 36 left. Here, 48 take 4 is 44 cans left. So we need to do it as a percentage of the total, so we need to work out how much is left in total. So 120, add 36, add 44. Okay, 4 add 6 is 10. 3 add 4 is 70, add the 10 is 80, 120 add 80 is 200. Now we need the cans of cola as a percentage, so the best way to do this is to write it as a fraction first of all, and again this is what you would do on your calculator. 120 out of 200, so there's 120 cans of cola left, there's 200 cans, so 120 out of 200. Now if you had your calculator, you just put this in and put next to it times by 100. We don't, so we need to turn this into percentage in a different way. Now remember, percentages are out of 100. So we just need to get this as an equivalent fraction with the denominator of 100. So divide by 2 and divide by 2. 120, half of that, well half of 12 is 6, so we get 60. So what is that as a percentage? That is 60%, and that's my answer there. Next question is something which people, because it's kind of independent in most cases from other questions, is something which they forget how to do. You know, everybody should have done it or has seen it before. It's one of those things which people sometimes confuse or forget because division works slightly differently in terms of maybe how you would work it out. Now I'll show us 2 ways you can do this as well. One way is, one way is definitely more mathematically sound than the other, but they will both work. And the less mathematically sound way you might think is easier, but yeah, I'll show you. So what I want to do first of all is times this one, and to get it into a whole number. So times that by, well, it's going to be 10, 20, excuse me, 10, 100, 1000. My powers of 10 there are going to, but yeah, 10 times this is going to it doesn't actually move the decimal place, but you know, in terms of how you think about it, you can think about it that way. So times by 10 moves it once to the right, times by 100 another one, times by 1,000, or times by 10 cubed. So times by 1,000, that will give me 4. Times this one by 10, 100. So times by 100 will give me 32. Now I can work out the answer to that and then go back, basically do the reverse. Divide by 100, divide by 1,000. 4 times by 2 is 8. 4 times by 3 is 12, so we get 128. Then I've got to divide by 1,000 and divide by 100 to get to the answer to this question. So if I divide by 1,000, this decimal point is going to, for all intents and purposes, seem like it's moving to the left. So 1, 2, 3, that would be 0.128. Okay, so it would be 0.128, but I've then got to move this decimal point another 2 places to divide by 100. So it's going to be, it would have been 0.128, 0.00128. Okay, now that's the mathematically sound way of doing it. The other way, which I've, you know, people that struggle with timesing and dividing by 10, or you know, powers of 10, 1,000, 100, what will end up happening is that you will end up with the same amount of decimal places combined in your answer. So there's 3 in the question here and there's 2 in this number here. So 3 and 2 is a total of 5, so you've got 5 total decimal places in your answer. That should always work, because you know, that's essentially what's happening when we're dividing by 100, dividing by 1,000. So that's a way to keep track, to make sure you've divided it in the right way, and so on. Okay, moving on. Now these questions that I've got here are from an GCSE paper for maths. Exactly the same content, they just look slightly different, as you can probably see. A shaded semicircle is inside a circle as shown. The radius of the circle is 10 centimeters. The diameter of the semicircle is 8 centimeters. How many times bigger is the unshaded area than the shaded area? So we need to work out basically the areas. We need to work out the area of this, and we're going to have to do it in terms of pi, because this is non-calculator. So first thing to note is that to do the area we need the radius. So the radius of this semicircle is going to be half the diameter, so that's 4 centimeters. We'll work out the area of the shaded region first of all. Area of shaded part. And the way I'm laying this out here, it's helpful to lay your answers out in a nice neat format rather than all messy all over the place, because it helps you keep track of what you've worked out, but also it will help the examiner mark what you've done. So that is going to be pi times by 4 squared. Pi r squared is the area of a circle. If you don't know it, put it on a flashcard, and then we need to half that, so it's a half of pi times 4 squared, because we've got a semicircle. Now that gives us a half of 4 squared is 16, times by pi is 16 pi in terms of pi. Half of 16 is 8, so we get 8 pi centimeters squared. Next bit we need to do is area of unshaded part, which is what I'm writing down now. You probably won't be able to see because I'm left-handed. To do that we need to work out the area of the full circle and take away this semicircle. So pi times by 10 squared, so that's the area of the full circle, subtract the area of the semicircle, which we know is 8 pi. That's why I worked that bit out first of all. Pi times 10 squared is 100, so that's 100 pi, take away 8 pi. That will give us 92 pi. centimetres squared for the area of the unshaded part. Okay, now how many times bigger is the unshaded area than the shaded area? How many times bigger? So essentially, what do we need to times 8 pi by to get 92 pi? Is the unshaded area than the shaded area? Yeah, just got to make sure actually that, you know, what they're asking for is what we've done, because similar questions they can ask you for, you know, percentage of the total. So the total would be, you know, pi times 10 squared would be 100 pi, and we're not looking at that. We're looking at how many times bigger is the unshaded area and the shaded area. What do I need to times 8 by to get 92 essentially? So what we need to do is do 92 pi divided by 8 pi. Now pi divided by pi will cancel. So we've got 92 divided by 8. Now I need to work that out using my written method. 8 into 9 goes once. Okay, carry the 1. 8 into 12 goes once. Remainder 4. Decimal point 0. Carry over my 4. 8 into 40 goes 5 times, so it's 11.5 is my answer. 11.5. That's how many times bigger the unshaded part is than the shaded part. This next question is about indices. The reason I wanted to make sure we looked at this question is because, well, indices usually are relatively straightforward, depending on, you know, the type of question. But this question, for example, is relatively straightforward. It's got the order of operations in there as well. We need to do the brackets first. But also, when it comes to A level, you need to be confident. You need to understand your indices. The reason for that is because you get onto a topic called logarithms, which is very closely related to indices and your powers. And so, you know, if you're thinking of going on to something maths related, whether that's, you know, maths A level or core maths, you need to be confident with these. And they are really quite straightforward. Again, something you could put on flashcards, index laws. So we need to do the brackets first of all. And when we divide, we subtract the powers. So that bracket there is going to be 3 to the power of 12 take 5, 3 to the power of 7, divided by this bracket here, 3 to the power of 2 times 3. If it doesn't have a power, that means it's a power of 1. 3 squared times by 3 to the power of 1 is 3 to the power of 3. When we divide, sorry, I'll go back one step. When you times, you add your powers. When we divide, like I said before, you subtract your powers. So 7 take away 3 is 4, so it's 3 to the power of 4. Now this says in this question, work out the value of. So it's not enough to just leave it as 3 to the power of 4. We need to actually work out what the exact value of this. We need to work out 3 to the power of 4. So that is 3 times 3 times 3 times 3. 4 3s times together. Well, this bit here, that's 9. And then this bit is also 9. 3 times 3 is 9. So we've got 9 times 9, which is 81. Just gonna have a drink and then I'll move on to the next question. Just realised me having a drink is not a good angle on this camera. Note to self. Okay, that is, you know, these are towards the end of, I suppose, the crossover questions, I think, if I'm right. Yeah, these are kind of the second half of the higher paper questions now. This is another GCSE question as well, and you can tell it's probably again by the layout. Here is a tunnel for a toy train. The diagram below shows the cross section of the tunnel. So we can see it's, if we're thinking about the area, it's one big circle, semicircle, take away one smaller semicircle. AD is a semicircular arc of radius 10. Okay, so they've told us it's definitely a semicircle. BC is a semicircular arc of radius 7. the length of the tunnel is 30 centimetres, so actually this bit here is going to be 30 centimetres. Work out the total area of all 6 faces of the tunnel. Okay, so this is, although it isn't written that way, it's asking us for the surface area of this tunnel. We need to do the curved part, we need to do the inside curved part, we need to do this end section here and double it, and we need to do these rectangles underneath. Don't forget them. So it's 1, 2 at the back, 3 on the top, 4 underneath, 5, 6. Give your answer in terms of pi. First thing I want to do is work out the area of this, because I was about to say that would probably be the trickiest bit. It might not be, because I need to work out the curved section here as well, which can be tricky. Work out the area of this, because that's one of the trickier parts, and we've got the diagram for that as well. So we need to do this bit is going to be pi times by the radius squared, pi times 10 squared, and half it, because we've only got the semicircle, and we're going to take away this inside bit, so that's pi times 7 squared and half it. I've put them both over 2 as fractions, so that, you know, if we can't half 49 pi, which we can't, we can just take it away from 100 pi over 2. So we've got 100 pi over 2, take away 49 pi over 2. That gives us 100 take away 49 is 51 pi over 2. So this is 51 pi over 2. That's the area of that part there. So we've got 2 of those. So 51 pi over 2, add 51 pi over 2 is 51 pi, and we'll get to that in a second. And actually what I'll do is I'll write these down, I'll start writing it down. So we've got 51 pi over 2, add 51 pi over 2, gives me 51 pi. We need to now do these curved faces here. Now we need to remember how you do the curved, or work out the curved face of a cylinder and then half it. So if you've got a cylinder, in terms of doing the surface area of that, draw the net first of all. So the net is a rectangle and 2 circles. The circle is basically this bit at the end, although we've only got the semicircle minus another semicircle. The height of this cylinder would be 30 centimeters, because that's the depth, if you like, and actually this curved bit here would wrap around the circle, so that's going to be the circumference. So that's going to be pi times by the diameter. Now the diameter of this circle is, well, the full thing, because I'm doing the outside bit here, is 20, so that'd be pi times 20. So then do the full outside of, if this was a full cylinder, we do pi times 20 times 30, because you work out the area of the rectangle. So 20 times 30 times pi, 2 times 3 is 6, 10 times 10 is 100, so we get 600 pi, and that would be if it was the full outside area, curved surface. We don't have that, we've got half of that, so it's going to be 300 pi. So at the bottom here, add 300 pi. We then need to do the same thing, but for this inside curved surface. So I'll do another net of a cylinder. And now the diameter of the inside bit is going to be 7, add 7, so 14. So that would be 14 pi, would be the full circumference, again times by 30, because it's, you're working out the circumference but then you're timesing it by 30. So 14 times by 30, I'm going to need to work that out with a numerical method. Basically 3 times 14 then times by 10. 3 times 4 is 12, carry my 1. 3 times 1 is 3, add the 1 is 4. So we get 420 pi. So this bit here is 420 pi. So add on 420 pi, and then we just need these rectangles here, which are 3 by 30. So that bit is 3 times 30, which is 90, and that's 90 as well. So we've got 1, 2, 3, 4, add 90, add 90. So our final answer, 51 pi over 2, add 51 pi over 2, is going to give us 51 pi. So we've got 51 pi, add 300 pi, add 420 pi. So that's going to be add 720 pi. 90 add 90. They're not pies. They're not 90 pi and 90 pi. They're just 90 add 90. So that's add 180. So 51 add 720 is going to give me 771 pi plus 180. Units are going to be centimetres squared. I've just realised very quickly that I've made a slight mistake. The mistake is not halving this. This is not 420, that's 210, because it's half of the curved area, 210. So I just have to go back and change that. 210. So that will change this bit, which will change your final answer. 300 add 210 is 510 pi. 51 add 510 pi is 5 add the 1 is 60. So 561 pi add 180 centimetres squared. And that's the whole thing, which is centimetres squared. Just cross that bit out. I hope that makes sense. This rectangle here represented the whole curved surface area of a cylinder, but we've got half of it here, in the same way that we halved this one. 561 pi plus 180 centimetres squared. I hope that makes sense. If it doesn't, feel free to type it in the chat. And you know, I haven't done these questions beforehand. I'm doing them live, so you can see my thought process, and hopefully that's really, you know, hopefully that's useful, because that's the exam technique that I'm talking about. What you need to know and understand and practice. There's actually what is the question giving me? What do I need to know? What clues do I need to pick up on? So yeah, I'm doing them live. Sometimes I'll make very slight errors like that, you know, but part of that is also checking over your work as well, and looking at where you might have gone wrong, where you haven't. The other questions that I've got, I'll save till next time. And before I finish, what I will do is I'll go through this question, which I used as a thumbnail. How did we solve this question? Okay, looks a bit scary, looks a bit tricky. Read the question first of all. Don't be put off by what it looks like, and actually break down what you can do and what you can work out. Also look at the diagram. What clues, what hints does that give you? Points A, B, C and D lie on a circle. So A, B, C and D lies on a circle, and we've got E down here. C, D, E is a straight line. Okay, so that's useful. That's an important point. Make sure we don't forget that later on. BA is equal to BD. We can tell that by these lines here through the sides. That tells me that BAD is an isosceles triangle, so these angles are equal. So before I go any further, I'm going to work these out. 180 take away 40 is 140 degrees. Now that is split equally because it's isosceles. These base angles at the base of these two sides must be equal. Just as a note, base does not mean the bottom of the triangle because it depends on the orientation. It means basically the bottom of these two sides. So if the triangles turn around, it would, you know, say it was that line was here, then these two would be equal to each other. It's not always the bottom of the triangle. Depends on the orientation, which way round the triangle is. Now 140 is split between those two. So 140 divided by 2 gives me 70. So each of these are 70 degrees. Okay, let's carry on reading the question. Angle ABD is 40 degrees. They've already got that on. Check, because quite often they'll give you information that they haven't put on the diagram. So check that they have. If they haven't, put it on yourself. The diagram here is your friend. It's going to help you visualize and see what you need to see. Without it, it would make this question virtually impossible. Use diagrams whenever you can. because they will help you, as well as the examiner, but mainly yourself, work out the answer. Work out the size of angle ADE. So we're working out the size of this angle here. Now we know that CD is a straight line, so if I can work out this angle, CDB, then I will be able to work out, by subtracting these two, 70 and CDB, from 180 to get this angle here. Now, what we need to think is, we've got a circle here. What do I know about, basically, shapes in circles? Circle theorems. I know circle theorems, and can I use any of them? Well, have got 1, 2, 3, 4. I've got a quadrilateral here, so it's BADC, this quadrilateral. Now, because all four corners, all four vertices are on the circumference of that circle, it's called a cyclic quadrilateral. Now, with a cyclic or cyclic quadrilateral, vertically opposite, so not vertically opposite, I should say, excuse me, not vertically opposite, opposite angles of a cyclic or cyclic quadrilateral add up to 180 degrees. So this angle at A, add this angle here at C, must add up to 180. So 180 subtract 70 will give me this angle here, and that is 110. Now again, if you notice, we have got lines here through the sides of this triangle, which means it's isosceles again. So if we do 180, take away 110, we're going to get 70. We know that because we've just done it up here. Now 70 is split equally between these two angles in that triangle, the base angles, because it's isosceles. So 70 divided by 2 is 35. So that angle there is 35, and so is this one. Now, just like I said before, we are going to use this fact that they gave us at the start. CDE is a straight line. They need to say that. If they don't say it, you can't assume it. It's a straight line. So 180 subtract 70 subtract 35 will give us the answer. I'm going to need to do my written method, but I do know 180 takes 70 is 110. We did that earlier. So I've got 110 take away 35. Okay, so I'll use my written method. 110 take away 35. Can't do 0 take away 5. So borrow 1 from my 10. So that's a 0, carry my 1. 10 take away 5 is 5. Can't do 0 take away 3, so borrow 1, that's 0, that becomes 10. 10 take away 3 is 7, 75. So this angle here has to be 75. Now it says here you must give a reason for each stage of your working, so we have to give reasons. Now, I didn't see that till now, so what I could do is, basically I'm going to rewrite this and I'm going to write down my reasons, which I explained to us before. So I'm going to write angle, which was the first one we worked out. It was, I'm going to put angles because both of these are important. B, A, D and BDA are 70 degrees as angles in a triangle add up to 180 degrees and angles at the base of an isosceles triangle are equal. So that's the first bit, and that's told us how I've got those 70s there. Next bit, I got the 110. Opposite angles of a cyclic or cyclic quadrilateral add up to 180 degrees. I nearly put 180 degrees Celsius then. So therefore angle BCD is equal to 110 degrees, and you might want to put this bit in brackets. 180 minus 70 is 110. It's absolutely fine to bullet point these as well. You do need to put down your reason and what you've worked out as well, but you need to put it down, importantly, in the order that you've done it. It shouldn't just be, basically, you've worked out the answer, here's every reason I can possibly think of, because that will not get you any marks. You need to put down the reasons that you need to work out the question. So we've got the 110 from the 180. Angles, actually I'm just going to put angle because I only need to know this one here. Angle CDB is 35 degrees for the same reasons as this one, and you have to write it again. Seems frustrating, but you need to. As angles in a triangle add up to 180 degrees. And angles at the base of an isosceles triangle are equal. So now we've got 35, we've already got the 70, and then we can just put angle ADE is equal to 75 degrees, as angles on a straight line add up to 180 degrees. Done. But that's the way you need to lay your answer out to a question like this. Okay, that's the last question I'm going to go through because I've gone 10 minutes longer than I wanted to. I hope that was useful, not only obviously going through the questions, hopefully that was useful, but also talking about, you know, the methods and what you need to be doing to revise, but, you know, use different methods, make a timetable, make a plan and stick to it. Okay, you're holding yourself accountable for that, really. Nobody else is going to say, oh, you haven't stuck to it, but it's important for yourself so that you don't look back and go, oh, I could have done this, I should have done this. Because ultimately I can only do so much in these hour sessions, and you will know what you have to work on. It's very personal. And one thing I did when I had this timetable, sticking to it, I did this really for my A levels because I found that trickier, you know, to revise for. But there's no reason why you can't do it with your GCSEs as well. Is motivation and actually making sure you've got enough motivation to stick to what you need to do, remembering why you're doing it. And there's lots of useful motivational videos that I watched and used on YouTube just to keep me positive, and thinking that, you know, I'm doing all this hard work, but it is going to have a result at the end, and it is going to work out, and, you know, it is going to give me improvement in whichever subject you're looking at. So yes, you know, if you're struggling with sticking to your timetable, I'd suggest, you know, finding and watching some motivational videos to really kind of reiterate back to yourself why you're doing this, and why you want to do the best that you can. Okay, I'll leave it there, and like I said at the start, if you like the videos, if these are useful and if you're enjoying them, then please like the video because it helps me see that. And yeah, I'll see you in the next one next week. 10:30, same time, Sunday, and you can watch it back later on if you can't watch it live. Okay, see you in the next one, people. Bye bye.